The last part of normal distributions that we're going to take a look at is using our calculator. So we're going to go back for a moment and take a look at standard normal probabilities without a calculator, and then we're going to do it with a calculator. So really quickly, just going back to what we knew before, using your table, we're going to look at what is the probability of earning at least an 88% on a test if the mean is an 82% and the standard deviation is 3.6. So quick recap, my mean is 82%. I want at least an 88, so I want from an 88 on up. So in order to do that, it's not an exact standard deviation away because one standard deviation is 3.6. So therefore, I have to convert this into my z-score. So it's the score I'm looking at minus my mean divided by my standard deviation. My z-score is therefore 1.7. I go to my table, I take a look at that sheet. Make sure you have that sheet. You will get one of those on an assessment as well. And I look at that and I see from there down is 95.54%. So if I want at least an 88%, I want above that, so I do the complement to it. So therefore my answer to this problem is 4.46%. Not too tough, but it does definitely require you to use your sheet. So we have from memory, knowing each of those divisions, 34%, 13.5%, etc. We have using our table, knowing that the table tells us from that specific z-score down. And now we're going to look at what do we do with our calculator. So make sure you have your calculator out. We are going to be looking at the following button. It's called normal CDF, cumulative distribution function. So it's a normal curve. That's why it's a normal in front. And then CDF says I'm finding it from a specific value between there. Then there's going to be a parenthesis that's going to open up. Depending on the year of your calculator, 83 pluses, 84s, silver, standard, whatever it is, will all fit the following criteria. If you have something different, I may have to work with you on that. We start with a lower bound. So I have to give it a really, really small value if I'm going all the way from the bottom, comma, an upper bound. So if I'm going from a value on up, I have to give it a really, really high value, the mean, and the standard deviation. So this is the order you are going to put these values in. Lower bound, comma, upper bound, comma, mean, comma, standard deviation. So we're going to have to type all of this in. Make sure you know where your comma is in your calculator. So if I'm looking at from this specific value on down, I'll call this A. If that's the case, what I'm going to type into my calculator is I'm going to find the normal CDF button. So give me a second and I'll help you find it. And then I need a lower bound. There is no lower bound on this. It keeps going forever towards the left direction. So I give it a negative value, a really, really technically small negative value. So I can't put a parenthesis in there, sorry. So negative 10,000. Okay, now maybe if I was dealing with numbers in the thousands, maybe I'd have to go to 1,000,000. Now if I was dealing with single-digit numbers, maybe I could just go out to negative 100. Kind of depends upon what kind of information we're looking at. So this number can be anything we need. It just has to be very, very far in the left direction. Comma, an upper bound is just my A value because I'm going from A down, and then whatever my mean is and whatever my standard deviation is. Now, let's say instead of going from A down, I'm going from this value, I'll call it B, up. If that's the case, I do my normal CDF. This time my lower bound, my lowest value is B. My highest value keeps going forever, so I'm going to pick a really, really big number. Maybe 10,000, maybe 1,000,000, maybe 1,000,000,000. Then my mean and my standard deviation. Now, the one that's really helpful is when I'm going between. This was kind of a pain when you had to do it by hand, because if you had to do it by hand, then you had to find from A down, from B down, and subtract them using that sheet. Now, my calculator does all the hard work for me. It's just a normal CDF. My lowest value, A, so I went from here to here, sorry. A, my highest value is B, my mean, and my standard deviation, and it does all the hard work for you. So now, we're going to practice that previous example that we just did using our calculator. So I'm going to go back to this problem. So using my calculator, I'm going to do my normal CDF, and then I need my lowest bound, which is 88. Maybe I'll put this on the next line. So this keeps going. So my lowest number is 88. My highest number, let's put in 10,000. That looks like it should be enough. My mean is 82, and my standard deviation is 3.6. So I'm going to type all of that directly into my calculator. So, calculator up. Normal CDF. Hit second, and then your vars. So second, and then your vars. Normal CDF is number 2, not the PDF. PDF is at a specific location. CDF starts at 1 value and goes down, or between 2 values, excuse me. So now I type in, according to our sheet here, the lowest value was 88. So 88. And then my comma, which is above your 7. My upper bound, we said we're going to put in 10,000. Comma. My mean for that was 82. Comma. And my standard deviation is 3.6. Hit enter, and it tells me it's 0.04779, which is 4.779%. 4.77, yep. That is as exact as we are going to get. So if you notice, those are not exactly the same. They are definitely off by a little bit. But that is going to happen. The table is less precise than the calculator. And the memory ones are even less precise. So read this example and go through, and instead of using your, so we're going to do this both ways. We're going to do our normal table, and then you're also going to punch this into your calculator. So pause this, do your normal table, and then we'll go through it with your calculator. So when you use your table, convert it to my z-score, got negative 1.6. Looked at my table, got 5.48%. Perfect. So now I go to my calculator, and I do my normal CDF. Low number, it keeps going forever in the left direction. So I'll do negative 10,000. That looks like a sufficient value. My highest value is 50. My mean is 73, and my standard deviation is 14.1. So go to your calculator, punch all of that in. Hit enter. And it gives me 5.14%. There's my more exact percentage. Okay. Next one. Go ahead, read it. Draw your picture. Use your table, and then go to your calculator. So for this one, I had to find my complement because I was finding from 5.1 up, which means my table finds from 5.1 down. Subtracted it from 100. Going into my calculator, normal CDF, lowest value, 5.1. Highest value, 10,000 will work. 4.6 is my mean, and 0.4 is my standard deviation. Okay, pause it, hit in your calculator. And you get 10.56%. No need to do any subtraction. It physically tells you the value. Again, a little bit more specific than what we get when we do our table. The last example that we're going to look at deals with, now I'm giving you the percent. You have to find what your score is. So that's very similar to the problem that we did before using our test data. What our calculator, or what we're going to have to put in our calculator, is called the inverse norm. And then you are going to put the actual percent in there, okay, wherever it physically falls. By doing the inverse norm, this finds your z-score. This will physically find your z-score. So then you'll know exactly where you fall along the way. So back to our data. My mean is 73.9. My standard deviation is 13.4. I need to know what score would I need in order to be in the top 10%. So what the calculator will help us do is it will find our z-score for us. We also can do that by hand, so we're going to do it both ways. So if I take a look at my chart, I need to be in the top 10% or in the 90th percentile. So from 90 on down. So I now need to find my z-score. So I look at my table. I find 90%. We did this. It gave me my z-score as 1.3. Therefore, I set up my equation. 1.3 equals x minus my mean divided by my standard deviation. And that tells me the physical score I need, that's x, is 91.32. We had to use a table to find my z-score. Now, using your calculator, you are going to do your inverse norm instead. So I do inverse norm of 0.9, okay, because it's 90%. So now I go to my calculator, inverse norm, hit second, and then vars, it's the distribution, it's number 3. So again, second, vars is number 3. It's the distribution. And then I put in 0.9, and it gives me 1.28155, etc. So that is my z-score, which is 1.28. So now I set up my equation just like I did over here. 1.28 equals x minus my mean divided by my standard deviation. Therefore, the score I actually need is a 91.07. That's the score I physically need to get on that test to be in that top 10% or in that 90th percentile. So using our calculator, normal CDF finds between two values. Inverse norm physically finds my z-score.